Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at dynamic memory allocation. Specifically, we're going to take a look at the malloc function, and we're going to dig a little bit deeper in this. This video assumes that you've already set up your pointers demo and potentially have also watched the stack versus heap video, although we will be going in a slightly different direction in this video. It would be useful for you to go ahead and watch the stack versus heap to sort of understand why we need the ability to dynamically create an array or create an array of some arbitrary size rather than a fixed size. So to begin with, what this assumes is that you've obtained a copy of our malloc_01. And at this point, what we want to do is we simply want to copy over our function signatures and add them to the list of functions in our pointers driver, as well as the stubs for the functions. Now, at this point, what I would encourage you to do is to go ahead and build your pointers driver just to make sure that you have a working setup. And what we'd like to do is we'd like to go ahead and set up the switches and update our help to be able to handle this additional example here. So we'll start off here with an else if and our string compare I. And we're simply going to check to see if our argv square brackets 1 matches our malloc_01. And if it does, we simply want to make a call to our malloc demo. So if you got that working, then just take just a second then to come down here to the help and go ahead and update your help as well. So in this case, it's going to be malloc_01, and that simply will make a call then to the malloc_01 example or demo. I encourage you to improve on the help as you go along. Now, if you go down to the bottom of the file where our functions are, you'll notice that I have two functions. Essentially, our malloc_01 is going to act as a driver, if you would, for this display int array, this little helper function here. And this little helper function is very similar to the one that you saw in the stack versus heap video, if you've already watched it, with just a slight twist or a couple of different twists here. First, we want to go ahead and have a separate display function for each data type, and that just allows for us for future expansion in our pointers demo. So for instance, if we decide that we want to also display a structure or array or a specific type of array, then we've got that flexibility. Whereas if we have a more generic function like display_array, then we can only use it for one data type, or we have to have some fancy logic in there. So it's essentially a minor thing. And then the other thing is we're going to display the data just slightly different in this particular example. But other than that, essentially, this function behaves the same as the one in the stack versus heap. So let's go ahead and get started. And the first thing that we want to do is we want to go ahead and declare a variable index that will allow for us to loop through each one of the elements in the array. And the second thing then we want to do is we want to go ahead and check to see whether or not the array is in fact null. And so if the array is equal to null, essentially that means that a empty array was passed to this function. We aren't prepared to handle that. Instead, what we want to do is we want to provide to the user a printf of something along the lines of error, no elements in the array. And I guess a better way of looking at this is not that we aren't prepared to handle this, but we want to make sure and handle that particular scenario. The other thing you'll note in this function is an integer return value. The idea is that we want to return back to the calling function whether this function was successful or if it failed. And the easiest way to do that is to create another temporary variable. In this case, we're going to call it a results. And what we can do here is we can initialize our results equal to exit success. And if there is a situation like, for instance, where the array was null, we simply say results is then equal to exit failure. And instead of returning 0, we simply return the results. And now you not only have a little more robust display function, but you also have one that communicates back to the calling function what happened inside of that function. Now, assuming that the array is not equal to null, in other words, that we've hit the else branch, we want to do something. And that do something means that we want to print out a couple of pieces of information. And this is where we're going to deviate just slightly from the first example. In this case, what I would like to do is I would like to actually print out the length of the array. And so I'm going to simply say length equal to %d followed by a colon. And I'm not going to have a new line here. You'll see why in just a second. I basically want us to have a nice way of presenting the growth of our arrays. And so in this case, then what we want to do is we simply want to pass to that %d the length variable that is provided for us, which brings us now to another question or another piece of error checking that we should do, and that is we also want to make sure that the length value is greater than or equal to 0. So a further error checking might be to say else if, and in this case then what you would want to do is you would want to check to see if our length was less than 0. It is okay if we had a 0 length here, although it would kind of be a little strange to pass, or it would be strange to pass an array that was not null, but to pass a value of 0 for length, because that essentially would mean that you, even if you had a valid array, you would just be displaying none of the values in there. But once again, that technically wouldn't be an error, but it would be an error if somebody gave you a negative value here. So we would just say here, error, a negative length was provided. And furthermore, what you could do, you could actually go so far as to include what that value was. So in this case, %d, and then we would simply, once again, provide the length and as that input argument. Once again, then this would mean that our results were in fact a failure. So we would set our results equal to exit failure. Hopefully you can see now here where some basic argument validation is really useful here. So continuing on with this, now that we have printed out the length, what we would like to do is print out all of the elements in the array. And what we'll do here is we will print out all of the elements in the array with spaces in between them, except for the last value in the array. The last value in the array we want to print with a new line, so that essentially then we only have, our array on a single line. Now that's going to lead to some limitations in the future, particularly when our arrays get longer. But once again, this is just meant to be a nice demo function, a little helper function that'll help display the values in our array and see how our array changes as we grow it and then later on shrink it. So what we'd like to do here is set up a for loop using our index variable, and we'll start off at index equal to 0. We'll continue while index is less than length, and we simply increment our index. And then inside of the for loop here, what we want to do is use a printf, and we're going to have a %d followed by a space. And then what we want to do is we want to use the array and then whatever index we are currently at inside of our for loop. And that is what we're going to put inside of or pass to the %d. Now notice just a second ago, I said that we wanted to stop one element early. And to do that, what we'll do is we'll simply stop then our for loop at length -1. This allows for us then to follow up with an additional print statement, printf, using %d followed by a new line. And in this case, then we have to specify our array square brackets index. Now, the challenge here becomes then, do we want to handle a 0 length array? So in other words, a situation where the user provided us a valid array, but the length was in fact equal to 0. And so this is now where we're going to run into a little bit of a question here. So earlier we said that we had been provided a negative length array if we check to see if our length is less than 0. So that means it could be 0 or more. But then what happens here is, despite the fact that the user provided us with a valid length, we're still trying to print out that 0th index or that 0th value. So we want to be careful about how we handle this, because if you recall now, in this scenario, our index has not yet or has been initialized rather to 0 here. So this will still go ahead and print out the 0th element in the array. So if anything, what we want to do is we want to go ahead and change this now to length less than or equal to 0, and maybe even provide then a error, a negative length, negative or 0 length was provided. Okay, once again, just a couple of different ways for us to go about doing this. This is meant to be sort of in contrast with the previous example. Now, at this point, we've set up our little helper function. This should look fairly similar to some of the earlier examples when we were using for and while loops, except the difference being is we've got a little bit of extra logic thrown in here. Now let's get to the calling function. So what we're going to do is we're going to have several of these malloc demos, and in all of these cases, we're going to call then our display int array, or at least in several of them. So what we want to do now is we want to get started at creating a array, a one-dimensional array for us to use. And this time, instead of passing the arguments from the command line, what we would like to do is we'd like to interactively provide from the user a value that we can then use to dynamically allocate this array. So we're going to need a couple of temporary variables here. The first one that we're going to want to have, of course, is just simply going to be our results. Okay, and we're going to use that then just simply to determine exit success or exit failure. So what we'll do is, just like earlier, we're going to be optimistic here, and we're going to just assume that we're going to have success. And in this case, then we are going to return our results. The second temporary variable that we're going to need, or the second variable we'll need to help set this up, is going to be a value or variable that'll store the value for the total number of elements in our vector or in our array. And so what we can do is we can call this something like our n max, or we can also call it something like length. Now, I'm going to intentionally call it something different here, just so that you can see that the n max is how we're going to refer to it outside of our calling, outside of the function that we've called. So in other words, outside of our display function, just so that you can see a little bit of variation here. So in some cases we'll use n max, and in some cases we will use length. But essentially in both examples then, the n max is going to be the length of our array, which means that we are also going to have an array, or specifically a pointer to a array of integers. And in this case, then what we do is we're going to declare an array, except what we're going to use is we're going to use the pointer notation. So rather than array and the square brackets. And we'll get back to this in just a little bit. You'll hopefully see what we're trying to do here. So to begin with, what I want to do is I want to go ahead and initialize our n max, set it simply equal to 0. And what I'd like to do is I'd like to set up a while loop that will allow for us then to collect from the user a non-zero value greater than 0 for the number of elements in our array. And so in this case, what I'm going to do is I'm going to have while n max equal to 0, or better yet, less than or equal to 0, because we're not going to allow for them to create a zero element array. What we're going to do is we're simply going to prompt the user, printf, please enter an initial number of values, okay? Or once again, if you want to put in length, and then of course followed with a new line, and then the companion scanf, which is going to accept a %d, and the address then of our n max. And so at this point then, this while loop will continue to run until it's provided with a positive integer. Now, you would probably also want to logically have a maximum value here, because you don't want to end up with any sort of issues in memory. As a matter of fact, this is something that might be fun to test to see what happens if you put in too large of a value here, what happens with malloc. And so what we'll do here, though, is we're going to assume for right now that the user puts in some reasonable positive value. And at this point, what we want to do is we want to make a call to malloc, which allows for us to dynamically allocate memory. Okay, so call to malloc to essentially declare or allocate a chunk of memory. And to accomplish this, then what we'll do is we will simply say our array is going to be equal to, and initially what we'll do is we'll start off by using the malloc function, and whatever the value is for n max, in other words, that's how many values we want to store, times the size of a single value. In this case, we're going to be storing the integers in this array. This is an integer array that we've created, so we need to know the size of an individual integer, and we simply multiply it by how many the user wants. Now, with malloc, malloc is going to return a pointer. And what we will see is that we have to specify specifically that we want to cast that to a integer pointer. And if you're not yet familiar with that, I encourage you to look at some of the earlier videos in this series that focuses on pointers to a specific data type. And so what we'll do is make a couple of notes here. So malloc will return a pointer that should be cast to the correct data type pointer. So in this case, since we are dealing with integers, then we would want a pointer to an integer. Now, at this point, it's simply up to us to fill this array. And so for this example, what we're going to do is we're going to once again leverage a index variable. As a matter of fact, let's go ahead and create another temporary variable up here in our list. So we'll call this one int index. And the idea being here is we're going to simply just continue to prompt the user for a value. And so something like for index equals 0, index less than our n max, and then index plus plus. What we're going to do here is we're going to have a printf that says, please enter a value, enter an integer value. And then simply follow that up with a scanf. And you've got two possibilities here. One, of course, in both cases, we are going to collect it as a %d, but you can create another temporary variable that will store the results of this scanf, or as you saw in an earlier video, you can actually address your array directly by simply specifying the address of a specific element. So what I'd like to do for this example, at least to get us started, is I'm going to create one more temporary variable. In this case, I'm just going to call it value, and I'm going to store it at ampersand value. So in other words, at the address of the value variable. And at this point, then what we can do here is we can say array square brackets index is simply then going to be equal to the value. Now, what I'd like to do is I would like to now pass this array to our display integer array function. And I'd like to do this several times so that we can sort of understand what is in fact going on here. And so in the first case here, what I'd like to do is I'd like to first understand how this array variable works. So before we even get started here, even before we enter in an initial number of values, what we want to do is we want to take just a second to refresh our memory and to understand exactly what this array variable is. And so to begin with, what I'd like to do is I would like to specify the address, or the address stored in the array variable. And that is going to be, tell you what, let me shorten this up just a little bit. So the address, or the address in, I guess that's going to be about as best we can do there. But more importantly, though, that is going to be a pointer. And at this point, what we will do here is we will simply specify the array variable. The second thing that I would like to do is I would like to then have a address of the array variable. And my hopes are that we'll start to understand what the differences here in this notation are, especially as we start to look at passing this array to the function. So in this case, what I'd like to do is I'd actually like to specify ampersand array, or the address of the array. Now, we'll go ahead and build this real quick. We should have success. And then at this point, what you need to do is come over to your command window. And what we'll do here is we will cd to our pointers demo. We want to run our pointers demo first, of course, with the /h, and you'll see that we now have that switch handled for malloc. But specifically, when we run malloc_01, you'll see that the address in the array variable, you'll note there is a low value. Essentially, it's whatever value was there when we declared the variable, because we have not yet initialized our array variable. Notice that this is basically almost immediately after declaring the array. So at this point, quite frankly, we have no idea where it points to. But notice now the second line, the address of the array variable. In other words, that's where the array variable itself is stored. And in this case, you'll see that it's one of the memory addresses, at least similar to one of the memory addresses that we saw in an earlier video. So in this case, it's FEBC. And what I'm going to do here is I'm going to open up Notepad, And I'm going to take a second to make some notes off screen of some of these addresses so that we can track them, and then I'll bring them back as we see fit. So I would encourage you to grab a piece of paper real quick and just note what some of these addresses are, and particularly only the last 4 values. So in this case, FEBC. Now, at this point then, we should be ready to call our printf and our scanf. What I'd like to do is I'd like to go ahead and hit Control-C here, escape out of this for just a second. And I want to do the same thing as my pair of lines here. I want to copy these. Now that you sort of understand the purpose of this, I want us to then come down here immediately after our use of malloc. And I just want you to make a copy of these two. All right, so just for right now, just make a copy of those two before we go ahead and run this. This will help this demo flow a little bit better. And hopefully you'll start to see the point here. And then once we get through this demo here, then what we'll do is we'll work on calling our display function. Now, we're going to rerun this one more time. You'll see that once again, we're prompted. You'll notice that because we have statically declared the array variable, the address of the array variable, that stays, both of these values stay the same. The first value staying the same is rather coincidental. The second one's not as surprising because, as you saw in the earlier pointers video, that oftentimes a function will reuse the same memory location multiple times. But in this case, what we'll do is we'll just go ahead and answer the prompt here. Please enter an initial number of values. If I put in -1, I get prompted again. If I put in 0, I get prompted again. So our logic seems to be sound. And at this point, then I'm just going to put in 3 values so that we don't have too many. But notice now what has happened. So we have ran our malloc. In other words, we proceeded outside of the while loop. We've continued on. We've ran our malloc. Malloc has now allocated an array, in this case with 3 elements in it, and it has returned an address to a chunk of memory. And it has assigned it now to this array variable. So you'll see that the address of the array variable did not change. Only the address that was retrieved by malloc, in other words, of that chunk of memory where that essentially represents the first value of that array. So this right here represents the address of the first value in our newly created array. The second value represents the address of the variable that holds the address of our newly created array. So keep that in mind. That's the point. That's the distinction that we want to make here. And at this point, then what we can do is we can just follow with the additional prompts. It says, please enter an integer value. I'm going to be rather boring in this one. I'm just going to enter 1, 2, and 3. And then our executable ends in a very lackluster fashion because we haven't done anything. So what we'd like to do now is we'd like to leverage our display int array. So what we're going to do now is we are going to make calls to this function inside of our for loop. And we're also going to make one call outside the for loop before we even attempt to store any values. And we're going to do something a little bit strange here. We're going to call our display int array, and we're going to pass to it the array variable. But what we're also going to do is we're going to pass the value of n max. And the idea here is I want you to see how we slowly populate this dynamically generated array. Now keep in mind from earlier discussions that declaring or allocating a chunk of memory is not the same as initializing it. So effectively what we've done in this case in line 529 is we have allocated a chunk of memory, but essentially the values at that location or at those locations, for all intents and purposes, are garbage. They're junk. They're whatever was already there. And so to prove that, I'm going to make multiple calls to our display int array. Once before the for loop, and then once every time I run my for loop. And I want us to see now how our array is slowly being populated and essentially initializing or setting the values in the array that were in fact junk prior to this. So let's go ahead and build this now. And let's run this one more time. Let's go ahead and take a second maybe to split the screen so we can really follow the code along to appreciate what's going on here. Let's move this over just a little bit. There we go. And we should now be able to see most, if not all, of our code. The only part that we don't see is the complete printf here, but that's no problem. And so in this case, we're going to rerun our malloc _01. We're simply going to put in 3 values because that seems like a nice number. You can always put in more. And then you'll see here that I am printing out the array. And so I've made my call here to my display int array. And of course, it is not null. Its length is greater than or equal to, or is greater than 0 rather. So we're going to do something here. And what we're doing is we're printing out each of the elements in that array. Notice that these are just complete nonsense values. They're complete junk. We didn't put them in there. No idea where necessarily they came from, other than those were the values that were at that location in memory when you allocated it. So we are now inside of our for loop and our calling function. The first iteration here, we're being asked to enter in a value. We are going to oblige and we're going to put in 1. And if I hit enter, you'll notice that essentially I'm making a call now after assigning that value to the array at that particular location. I am now reprinting the array, and you'll notice in the command line that my first value has been changed from that nonsense value to, in fact, the number 1, which is what I had been replied to the prompt with. Now, for the second value, let's put in something else, just some number, let's say 54, and you'll see now that I am allocating, I'm assigning then the value 54 to the second value in that array, and then we'll put in some other value here, and there you go. You can see now how we have dynamically allocated an array using malloc, and we have now populated it, in this case using a for loop. Now, we're going to continue with this theme. As a matter of fact, we're going to follow this up with another couple of malloc examples. Particularly what we want to do is we want to notice that we have a limitation here. And that limitation being that we can allocate the memory once based on what the user prompts, or in this case, the user asks for. So in other words, we initialized the array using malloc, or we declared the array using malloc rather, to be 3 elements long. What happens if you want to change the size of an existing array? And so that's then going to be the direction we're going to go with this. But hopefully you can see now the benefits of using malloc and being able to control the number of elements in your array, in addition to the fact that this memory then is going to be maintained even beyond the scope of your function, which brings us to the last thing that you always want to do when you are done with memory that you have allocated using malloc, and that is simply to make a call to the free function. In this case, then, we will simply free our array, and to understand then what this does, you can once again go back and we'll make one more call to our printfs here. And we're going to go ahead and build this. And we'll run it one more time, a little bit quicker. So we're still going to do 3. We'll enter in the first value is 1. The second value is 54 again. Third value is 97. But you'll notice now here that the address in the array variable does not change. However, though the memory has been freed up to be used elsewhere. Okay, so the important thing to note here is that we have freed the memory, but it does not change the value stored in the array variable. If you wanted to truly make sure that that array didn't accidentally point to a place in memory that you did not want it to, then what you could say is you could follow it up with something like this. The array is equal to null, and you could even go so far as to go ahead and cast this once again to a pointer to an integer. So something like this would be, in fact, perfectly fine. And so this right here, just keep in mind the free function basically returns the memory back to the system. However, it does not change the fact that this array variable is still looking at or pointing to that block of memory. So just be very careful about that. If you were to accidentally use this array again after making a call to the free function, there would be no guarantee that the memory wasn't being used somewhere else in another function. So hopefully you found this video useful. As always, if you have any questions or comments, don't hesitate to ask, and thank you for watching.